Hello, myself Dr. Jadav. Welcome to the second session of Colorimetry. Here we are going to discuss about some laws of photochemistry. The first law of photochemistry is famously known as Draper law, given by the two scientists Grother and Draper. Let us look at the law. The only light which is absorbed by the system will produce a chemical change. This is the basic law. This law is also known as principle of photochemical activation. Once again, only those light which are absorbed by the reacting system can produce a chemical change. Let us know about the formulators. The Grothers, Theodor Grothers and John William Draper. Grothers was a German scientist and John William Draper was an American scientist. Let us look around the explanation. As you can see, when a beam of monochromatic light passes through a homogeneous medium, some of the radiations are absorbed by the solution IA. This is known as IA. Some of the radiations are reflected. These are denoted by IR, while some of the light or radiation are transmitted. This is denoted by IT through the solution. Thus, the incident radiation I0 is the sum of absorbed light, transmitted light and reflected light. This is the basic law Grothers-Draper gave. Let us look around the schematic representation for better understanding. Here, this is I0. This is nothing but an incident line. Here you can see the black dotted line is going through and is transmitted. This is transmitted light, while the blue one is the absorbed light and IR is the reflected. So according to law, incident light is equal to IR, that is reflected, plus IA, that is which one is absorbed, and IT, that is the light or radiation which has been transmitted. Let us look around the example of a glass. Glass reflects only 4% of light. Hence, the IR, that is reflected light, can be neglected. Thus, in case of glass, I0 is equal to IA plus IT. Grothers and Draper proved the law by the example of H2 and Cl2 in presence of light. Here, light is nothing but a source of energy. Now, absorption of light means absorption of energy, and thus the reaction takes place. And the primary effect is either an increase in thermal energy of the system, that is the reason why the reaction takes place, or there is a raise of electrons. Electron rises from lower energy level to higher energy level. That means activation of electron takes place. These are the two possibilities. These are the two primary effects. Either by increasing thermal energy, means when light source is absorbed, means energy is absorbed. This will either increase the thermal energy of the system, creating the reaction to be forward, or the raise of the electron from lower energy level to higher energy level. Electron lower energy level to higher energy level. The second law in our syllabus is Lamberts Law. This is very important law, and before we move towards Lamberts Law, we have been knowing this word Lambert along with Beard. So the law is famously, we have been knowing as Lambert-Pierce law, that we are going to discuss in our next series of lectures. The two scientists were Johann Heinrich Lambert and August Beer. Lambert gave his law in around 1760 and the advanced law was given by Beer in around 1852. Lambert discussed based on thickness and Beer discussed based on concentration. So Lambert-Beer law is the combination of thickness and concentration. Lambert law. What does the Lambert law says? When a monochromatic beam of light passes through a homogeneous medium, equal fraction of incident radiations are absorbed by successive layer of equal thickness of light absorbing the substance. Whilst Lambert law is based on thickness, we are talking about monochromatic light. A polychromatic light is somewhat like this. It is scattered in all directions, while a monochromatic light that we are going to use frequently is in single direction. These are monochromatic light in a homogeneous medium. Now the law is based on thickness. What does simply the law says? That if I distribute the medium in equal fractions, for example there are 1, 2, 3 and 4 fractions, the light, incident light will be absorbed in equal proportion. For example, if 10% light is absorbed in fraction 1, equal 10% will be absorbed in each fraction. So overall absorption will be 40% and remaining 60%, this is just maybe transmitted. So what Lambert discussed was the absorbance of light based on the thickness. So at each thickness, successive thickness, the equal amount of light is absorbed. So this law is based on thickness. Now the law states the rate of decrease in the intensity of thickness of the absorbing medium is proportional to the intensity of incident radiation. Means the radiation, this is the incident radiation, this is the transmitted radiation, this will be directly proportional to the thickness of this medium. Means if there is increase in thickness, if I will increase this thickness, there will be definitely decrease in this transmitted radiation. So increase in absorbance. So this is what the law stated. Directly it is related to thickness. The equations. Let us look around to the equations. Minus I by dt minus di by dt is directly proportional to I, where I is the incident radiation, di is the radiation, decrease in the radiation, intensity of radiation is denoted by di at particular thickness dt. Now di by dt minus di by dt is equal to k, where k is some constant, or which constant? Absorption or coefficient, extinction coefficient. I being the intensity of incident radiation or light, T being the thickness. The negative sign here is because there is decrease in intensity of light with increase in thickness. With thickness, the intensity of light decreases. Now, these are some mathematical formulas. Taking this I here and dt here will give this equation. Integrating this equation will get, this is integration of 1 by I at from I0 thickness 0 to thickness t from 0 to t, intensity at 0 time or 0 thickness to intensity of t thickness at 0 to thickness t dt, integrating from 0 to t. So on integration you will get this function. Further, when shifting Further, shifting this minus sign to the right hand side and removing ln. When you remove ln, it will give e raised to, the right hand side will be e raised to minus k1t, and shifting this I0 to LHS, the IT will be I0 into e raised to minus k1t. This is the mathematical formula, mathematical form of Lamberts law. So again, if we remove this, IT is equal to I0 e raised to minus k1t. If we remove this e, we have to add 10 raised to minus 0.4343. This is a mathematical form, we are not going to deal with this. So this is the actual expression where IT is the intensity of transmitted light, I0 is the intensity of incident light, A is the absorption coefficient, and this will be the molar extinction coefficient. So the intensity of transmitted light is exponentially decreases with increase in the thickness of the medium. So it is thickness dependent law. Thus IT by I0 is equal to transmitted, that is T, we can measure T, and the natural log of I0 by IT, inverse of IT by I0, is optical density. We all know T is inversely proportional to optical density, or we can say T is inversely proportional to absorbance. This is the end of the session 2. Thank you so much.